So we're picking up from the last video, and these are the values we got from the last video. Recall that if you were to take this, for example, and if you happen to have a calculator, which they tend to be pretty rare, that can do logarithms of different bases, by inputting this in a calculator, you get these kinds of values, right? Now, to my understanding, there's only a few handful of calculators out there that can calculate logarithms with different bases. I doubt you're going to go out to the store and find one that you really want to for that purpose. You're not that as obsessed as I am. I do happen to own 2 or 3 calculators that can do that because I am a weird person like that. Okay, but we were able to get these values by using the idea of ELB, that the exponent is the logarithm of the base. And so we continue this idea with part E, where it's equal to x, as we're solving for. And remember that the exponent is the logarithm. The exponent is, that means that the exponent is the thing by itself on the other side of the equal sign. So in part E, the exponent is going to be x because it's the thing on the other side of the equal sign. The base of the logarithm happens to be the base of the exponential. And then we have the leftovers go on the other side. Great. This is part E. Now, we need to get them to be the same base. 49, if we do a factor tree, is 7 squared. What's the exponent on this one? This one? Haha, very good. So, they're the same. Great. We can divide both sides by 2. Great. X is 1/2. Great. So, if you were to type this into a calculator, it would give you 1/2. Fascinating. Look at this observation, by the way, that if I type this in the calculator, I get 1/2. If I type this in the calculator, I get 1/2. Interesting. There could be a pattern here. Part F, same idea. We get x and we get a 1/3. Wow. This is going to be a lot of work. Wow. I have to get them to be the same base. Wow. I know that if I do a factor tree for this 27, I get 3 times 3 times 3. I need this to be a 3. So if I move it up here, it becomes a -1 power. And I happen to have the same base. If this is a little bit too much for you, review the video on exponentials. We did work there with these kinds of things. So they have the same bases. So like I said, I'm equal to each other. Divide both sides by -1. I get x is equal to -3. Interesting. So if I were to type this one in the calculator, part F, I would get an answer of -3. So again, us using ELB, right? We've done it so many times already in these videos, using the exponent is the logarithm of the base. Right now, we are doing problem 4, some math, right? But it's this review math that we did in previous videos. The review math is only allowable because of ELB, because of us being able to reorganize things. We have to be comfortable going from logarithmic form to exponential form, and sometimes going from exponential form to logarithmic form. Well, problem 5, here's all the equals you want. So, there you go. And everything's a logarithm, which means we're going to end up using ELB to make it into an exponential. So, we know that the 3 is the exponent. We know the 1/2 is the base. And this is the argument. Now, the nice thing about this problem is it's solved for us pretty much. Like, x equals whatever this is. So let's go ahead and do whatever this is. What's 1 to the 3rd power? That's 1. What's 2 to the 3rd power? That's 8. So the answer is 1/8. That's it. It was very minimal math. It was only possible because we did ELB. So look at the original problem. If I gave you this a few weeks ago, you could not solve it. You wouldn't know where to begin. Do I multiply by 2? Do I do this? What do I do with log? What the heck is log? You know, there was no chance. But now it's like, it's a matter of, okay, reorganize it with ELB and then just do your thing. Okay, part B. This is the exponent. That's a -1/2. That says base 64 equals x. Great. It's amazing because once we do ELB, which is the Algebra 2 concept, this becomes a middle school problem. Because I just have to simplify and do order of operations or whatever's got to be done. So negative means I'm going to bring it downstairs. So it'll become positive. And what is the 1/2 power? Well, that's a square root of 64. And at this point, if you haven't caught on to something, I'm trolling you. What's square root of 64? 1. It's 8. Actually, we don't use troll anymore, right? Is it still Rick Astley? Like, right? Did I just Rick roll you? It happens. So anyway, this answer is never gonna give you up, never gonna let you down, exactly. Okay, I can't get you 3 in a row, so this one I'm not gonna Rick roll you. I promise. Okay, this one here. The exponent is 2. The x is the base, and the argument is 9. Jeepers, this is a quadratic. This is we spent a good 6 weeks on quadratics. It's already set up for me to just square root and solve. So that's equal to plus or minus 3. However, we're not going to have a negative base because by definition, we said that it has to be positive, a positive base. So we're going to get rid of this minus and we're going to keep the positive 3, and the answer is just 3. Great. D, we have the 1/3 power. We have the 16. And that's equal to x. Again, we're doing ELB, right? We don't have to do fancy arrows everywhere. The exponent is a thing by itself, and here's a base. Boom. Now, this gets interesting because I'm looking for, if I want to do this the right way, this is cube root of 16. And if you do a factor tree for 16, you're going to get 2 times 2 times 2 times 2. And what the cube root is saying is I want things that come in groups of 3. So here is one group of 3. It pops out as a 2. And the leftovers stay on the inside. So what I'm proposing to you is that the answer is 2 cube root of 2. That's the answer for part D. That's a pretty messy answer, but welcome to Algebra 2.
Oh, yeah.
Okay, the exponent is 3/2. The base is x. That's equal to 8. Oh, wow. So, what if we raise this to the 2/3 power and raise this to the 2/3 power? That's a lot of Okay, and if I do that, these all cancel out up here, right? Because the 3 and the 3 and the 2 and the 2 leaves me a 1. That's x to the 1 power, which is x, is equal to 8 to the 2/3. Now, what does the 2/3 mean? It means that if I do this, the 3 goes on the outside, the 2 goes on the inside. Cube root of 64. Well, 4 times 4 is 16 times 4 is 64. So 4 times 4 times 4 is 64. So the cube root of 64 is fur. Most excellent. Good stuff. Some good stuff. These are problems, once again, these are equations that we couldn't solve any other way unless if we did ELB, and then we can use whatever skills we've collected along the way to solve them. So here's a problem that a student did, right? They're trying to solve for this, which means that they would have set it up, they made it equal to x. That's great, that's nice, that's beautiful. And then they did ELB, or maybe they didn't. They watched some other video somewhere, or they looked at the book and they tried to use the arrows and they just, yeah. So what should it have been? Well, this is not looking good. they made the exponent be 3. They made the base x, but the base is 27. The exponent is x, right? So the exponent is a thing by itself. This is the base on here, the 27. And that should be equal to 3. Good golly. Poor chap. And now we have to make the base equal to b itself. So that's 3 to the third is equal to 3. Right? Because 3 times 3 times 3 is 27. So that's 3 to the third power. This is the 1 power. And because they're the same base, I can set them equal to each other. I divide both sides by 3. I get x is equal to 1/3. Not 3, but 1/3. So we can finally write the actual official answer should be log base 27 3 is equal to 1/3. That is what it should be, not this abomination. For your summary, take some time to summarize some of the math techniques used in some of the above problems. So maybe you struggled with rational exponents, maybe you struggle with square rooting quadratics, maybe the prime factor trees, etc. Take some time to make sure you brush up on these things. Welcome to Algebra 2.